All right, today we're looking at the derivatives of inverse trig. Sorry, not on the first page. There we go, inverse trig and their derivatives. We're going to start with just a review of inverse trig. Now, remember, inverse trig functions have a limited range. The range for sine is negative pi over 2 to pi over 2. Same with tangent, or inverse tangent. And cosine has 0 to pi. Their reciprocals tend to have the same range. The only one that doesn't is arc cotangent. So arc tangent uses negative pi over 2 to pi over 2. Arc cotangent uses 0 to pi. So the idea here for just the general trig or inverse trig is saying what angle gives you 1 over 2. So for sine, we're looking from pi over 2 to negative pi over 2, or negative pi over 2 to pi over 2. The angle that gives us 1 over 2 would be pi over 6. Negative 1 over 2 is negative pi over 6. And then for arc tangent, negative 1 is negative pi over 4. Okay? Now, this really gets important when we look at the sine of arc tangent or tangent of arc sine, things like this. So remember that arc tangent represents the sides of a triangle. So arc tangent being 3 over 4, since it's in the first quadrant, because it goes from negative pi over 2 to pi over 2, we have an opposite of 3, adjacent of 4. And while this is not one of our normal 30, 60, 90 or 45, 45, 90 triangles, we do know what that other side is. We can figure it out by Pythagorean theorem. And now, if we're looking for sine of arc tangent, that just means sine of this triangle. So sine would be opposite over hypotenuse, 3 over 5. And you can do that with each of these to figure it out. The big one I talk about is this one at the bottom right. Sine of arc sine of x. Well, since sine and arc sine are inverses, that just means this equals x. But let's look at the triangle it creates. We have x, 1, because arc sine is opposite over hypotenuse. And then what would this other side be? Well, it would be Pythagorean theorem, square root of x squared, 1 minus x squared. There we go. Now this triangle is really important because this triangle helps us find the derivative of arc sine. So let's draw that triangle again, hide it out in the corner here. And let's say, instead of doing d over dx of arc sine, let's say that y is equal to arc sine of x. Let's say that this is a function we're trying to solve. And we're trying to find the derivative of it. Well, we don't know anything about the derivative of arc sine. But since sine and arc sine are inverses, we could do sine of both sides and get rid of that arc sine and just take the derivative implicitly. So we have cosine y dy over dx equals 1. dy over dx equals 1 over cosine y. And if we look back, what does y represent in this triangle? Well, y is arc sine, which means it's the angle that we're using. Okay, because arc sine gives us an angle, so that's y. So when we say 1 over cosine of y, well, cosine of this angle y, we don't know what y is, but cosine is going to be adjacent over hypotenuse. So that means the derivative of y is 1 over, and then square root 1 minus x squared. This is the derivative of arc sine. And we have all of these derivatives we could do. You don't need to do that every single time. You can just memorize that these are the derivatives. Now, in my class, you do need to know arc secant, arc cosecant, arc cotangent, even though they're not tested on the AP exam. But the only ones you need for the AP exam are the 3 on the left. Okay? Now, from here, it's just a normal derivative problem. So, derivative of arc tangent is going to be 1 over 1 plus the inside squared, so 3x squared, times the derivative of the inside, which is 3. So 3 over 1 plus 9x squared. Okay? Or this one right here, derivative arc cosine is going to be 1 over the square root of 1 minus the inside squared, which is just x, technically negative 1, times, and then the derivative of that inside, 1 over 2 square root of x. Now this one can be simplified a little bit more. We can multiply the square root of x into the square root, so x minus x squared. That's about it. Same with this last one. Now this one requires a little bit extra simplification at the end. We have 1 over absolute value of the inside, so e to the 3x, square root of the inside squared, so e to the 6x, minus 1, times the derivative of the inside, so 3e to the 3x. Now here's the thing, the reason this can be simplified more, this doesn't need the absolute value around it. Our e to the 3x is always going to be positive. So that means there's no absolute value actually there. The e to the 3x's can cancel, so this simplifies down to 3 over square root e to the 6x minus 1. There's not much more complex we can get with it, so let me know if you have any questions. You'll have a great day.